Welcome back to the Foundation in C# course. We are currently in Module 6, and this lesson, we're going to be covering a mini project. So this is where we're going to take what we've learned so far, which isn't too much, but at the same time, I figured it's complicated enough that I didn't want to go any further before we kind of put what we've learned together into an application to just see the similarities and the differences between interfaces and inheritance. Okay, so we're going to build a small project just to show off what these can do and how they'd work in a more real application. So let's start by going to and create a new project, and we'll do a console app. And like I said, we'll cover .NET Core in a little bit, but for right now, .NET Framework is fine. .NET Framework and .NET Core are so close together that it's not like you're missing anything going to .NET Core right now. And I think in some ways it'll actually be a negative because it'll be a little confusing for no benefit. So we'll get there, but for right now, .NET Framework console application. And we'll call this project the mini project. Let's call it inheritance. Call it inheritance mini project. Although it's both inheritance and interfaces, that's just a long title. And we'll call it app at the end and 472, and we're good to go. All right, now we need to add our console read line at the end, so that it stops the application. And now we need to think through what this application is going to do and how it's going to work. And so I kind of roughed out a mini application. It's not going to be terribly in depth, but that's not the purpose of these mini applications. It's not to be a complete start to finish application. The job is to connect two or more things that you've learned together, just to see how they interact and work together. And I've grouped what we're learning into a certain order so that it's good to see these two things especially together and the next couple things together because they're similar concepts, or they're concepts that usually you're finding together or may contrast. In this case, interfaces and inheritance kind of complement each other but also contrast. So we want to see that. So let's create a class. I'm going to call this class inventory item model. All right. So the idea behind this is we're going to have an inventory system, and we're going to ask the user to either buy things or rent things from us. And so we're creating this system where we can have purchases and rentals at the same time. Now, this inventory item model is going to hold certain things about the item, but again, we're keeping it really simple. So we'll just say that the title or the name of the product or whatever it is, that's what this is going to hold. Now, we have various different types of things in our inventory. For example, let's create a public class that's titled vehicle. So a vehicle is going to be an inventory item. We're going to have vehicles in our inventory. And a vehicle is going to have some extra properties. But I think that the biggest one is we're going to have a prop that is the decimal type. And this is the dealer fee. So vehicles have dealer fees, and so when you go to purchase something, there's the price of it, but there's also a dealer fee that gets added on top of it. Now, a vehicle is a inventory item model. Actually, we call it model. So a vehicle model is an inventory item model. So it's going to have a title, which would be the name. Let's call it product name instead of title. That way it's a little less confusing because a vehicle also has what's called a title, which is the it indicates that, what the vehicle is and who owns it and all the rest. And that's a little confusing, whereas this is a little more clear: product name. You don't want to call it just name because name is a reserved word, but product name is fine. So now a vehicle model has a product name and a dealer fee. Let's add some more items to our possibilities. So let's add a public class book model. We're also going to sell books because this is a really weird store. So we're going to inherit from inventory item model because we don't have dealer fees for books and we're not a vehicle anyways. But we do have a product name, but we'll also have a number of pages, which applies to books but not to vehicles. So there's a couple of different items now we have that inherit from the inventory item model. Now these are really slimmed down. There's a lot more that probably go into these things, but I think that's a good start for now. So let's talk through the next issue. So you want to have this list, and let's just create a list here. And we'll say it's a list of, let's start with just inventory model, inventory item model. And we'll call it inventory equals new list of inventory model. And now we can add different things to our Okay, so now we have a couple of items in our inventory. We want to be able to purchase these or rent these depending on whether or not the item can be purchased and or rented. And let's actually create one more class because this is going to make it a little bit more clear when you have the ability to do both. So books we'll say that books we can purchase, vehicles we can rent or purchase. And now let's create a new item. Oops, not prop. Wow. Public class. And this is the excavator. And this is also going to inherit from inventory model. And it's going to have a method called dig, public void dig. And that's just going to say, I am digging. Okay, so an excavator can dig. Now, an excavator will only rent. So we're only going to rent an excavator. We're only going to purchase books, and we can either rent or purchase vehicles. So how do we do that? Because it would stand to reason that we want to have a buy button or a buy method whenever we want to purchase something. So for a book, we would have a method here called buy that would actually check one out of the inventory and it would charge the user. Whereas that wouldn't be the case for the excavator. We wouldn't want to have a buy method because for the excavator, we'd only want the rent method or the return method. So rent would be to actually, rent the vehicle for a time period, and then return would be to return the method back to the place he rented it from. So how do we do that? We can't inherit from inventory item model. let's actually put a quantity here too. There we go, quantity stock. So how do we do this? Well, that's where an interface will really help us, because we can say public interface, and let's give it a name. Let's call it iRental. And so rental has a couple of options. One is to rent. And we won't worry about quantities or even how to do payments and all the rest. We're just making this a simple application. So we'll just say rent, and it's going to subtract 1 from the quantity, and it's going to say, hey, I've been rented. And then we'll create another one that is return rental. Don't just say return, because return is a keyword as well. Return rental, and that will do kind of the opposite. We'll add 1 to the inventory, and it will say, hey, I've been returned. Then we'll create another interface. We can say I buy, which is a little weird. I purchase a bowl. That's not great, but I think it communicates what we want. I may call this rentable. iRentable. That sounds a little better. So now we have a void here called purchase, which that's just going to say, remove 1 from the inventory or quantity in stock and say I've been purchased. That's it. Okay. So now you have these 2 interfaces. We can start applying them to different spots. So we can say, comma, iRentable. We can do our control dot here to implement the interface. And for the rent, we can say quantity in stock minus equals 1. So remove 1 from the quantity. And then say this excavator has been rented. Okay. Now, we're not doing a check here to see if the quantity is already 0. And if so, you can't do the rental. And that would be something we want to do in a more full application. But for this, it's just showing off what it can do, not making sure it does everything. This is one of those things about creating tests. You've got to be careful that you don't create bad habits in tests by ignoring best practices and doing things just awful. But on the other hand, you don't want to spend so much time on best practices and creating real environment both. So iPurchasable, and we'll implement that, which is going to say quantity in stock minus equals 1, and then this vehicle has been purchased. Whereas we're also going to implement the iRentable. So we need to implement that. And then down here, we have our rent, which is quantity in stock minus equals 1, and console write line that says this vehicle has been rented. Which that looks an awful lot like this. And you might say, well, it's only a difference of that message. And that's true for right now. And so if this is the way it's going to stay, then I might create a method that was called like remove from inventory. It's a private method. And then call it from both spots and just pass in the right message. But my guess is there'll be more differences in how we make a purchase. And therefore, keeping it separate is a good thing. So return for rental is quantity in stock is plus equals 1, and the message is this vehicle has been returned. Okay, so now we have these classes that implement the different interfaces, including this one that does both. And so now what we can do is, instead of just storing everything in our iInventory model, we have a couple of different options. One of the options is and we'll do it one more time. Var excavator equals new excavator model. And that should be excavator model, not excavator. And the reason I call it model is because a model is typically what holds data. Now, in this case, it's a little bit more like a full-fledged class. And so maybe you don't call it model, maybe call it something else. But I'm calling it model to be consistent then, at least. So excavator model, and we'll say that the product name equals, let's go with bulldozer. They're always fun. And quantity in stock equals 2. So now what I can do is I can say rentables dot add a vehicle, because a vehicle is rentable. And I can say rentables dot add an excavator, because an excavator is rentable. But if I say rentables dot add and try and add a book, it's going to say, nope, can't do that, because a book is not rentable. Now I can say purchasables dot add and add that book. And I can also add the vehicle. So now I have these two lists that have the items in them that I can either rent or purchase. Now notice that vehicle is in both. And we only create it once. And actually, this is not a problem or a memory usage issue to put it into both lists. Because remember, it's not that we're making a copy to put in the list. We're just saying, okay, you built this house over here at 123 Sesame Street. I'm going to remember in this list and in this list down here, I'm going to remember 123 Sesame Street because that represents this vehicle. So with that, we can actually use it in more than one list, and it's not going to cause a problem with our memory usage or other issues. So now what we can do is we can ask the user, let's do a console.write, do you want to rent or purchase something? And we can give them the options, rent, purchase. And then that's a console write, not write line. And now we can say string, let's call it rental decision. Either it's rental or purchase decision. But that's okay because if they say no to renting, then it's yes to purchase. Equals console.readLine. So it's going to read the response. And this is the check we're going to do. We're going to say if rental decision dot to lower, not to look up, to lower, which converts the text to lowercase, which makes it easier to compare, equals rent, then do this. Otherwise, do the purchase, which means that if they type out test, we're going to assume they want to purchase something, which again, that's one of those things we need to identify. Do you want to do that, or do you want to have an else if here that says, if it's purchased, do this, else you didn't give us a correct input. Okay, so we could make that a little more secure, but for now, I think this is fine for our demo purposes. So if the decision is rent, we're going to do a for each, and we're going to print out everything we could rent. So var, let's call item is fine, in rentables. And we'll do a print line where we print out, let's do our $ string interpolation format. And we'll say item colon, and then item dot, and let's grab the, well, the interesting thing is we don't have anything to grab. There's no title here. There's no product name, because the inventory item model, which everything inherits from, that's not what we're storing this as. We're storing it as a iRentable. And so rentable only has rent and return rental, which is kind of inconvenient. But what we can do is we can say, and this is one of those things that gets people people think it's a little squirrely at times, but it's actually a good practice. We can put in our iRentable and our iPurchasable, we could put this product name and quantity in stock because we already have those and we know that's what it's coming from. However, what we can also do is create a new interface. Public interface iInventory item. And we'll paste those in. We'll take out the public in both of them. And now it's going to say for an inventory item, for an iInventory item, you must have a product name and a quantity in stock. So we'll say that's what applies to inventory item model, which it already implements. But now for an iRentable, we can say, actually, it also has to be an iInventory item model. Whoops, not a comma, a colon. Okay, so now the iRentable and iPurchasable have to be iInventory item models, which means it's going to add these two interfaces together, which means that when I do control dot here, I have product name. Okay, so now I know the product name. And now I can say, so that's the item. I can say console dot write. Do you want to rent this item? Yes/no. I can say want to rent equals console.readline if want to rent to lower equals, and then we will say yes. So it's only yes now. Anything else is a no. Then if you want to rent, we will say item.rent. Call that method. Okay. Now I can do another one that says, hey, if you do you want to borrow? You want to return? Let's do that. So we're going to do this all over again. We're going to copy and paste, and this is dangerous. Be very careful with copying and pasting. You have to change everything. And sometimes you'll miss something. Notice down here, this isn't yelling at me, but it's checking the want to rent, not the want to return value. Make sure you change that. Also make sure you change, instead of rent, it's return rental. So that's why copy and pasting can be dangerous. Do you want to return this item? Yes or no. Want to return is a read line. And then want to return to lower equals yes, then item.return rental. So you kind of read through every line and make sure that it is what you're wanting the logic to be. So this will loop through every item that's a rental once you say you want to rent something. Now, let's do our else statement. And so this means they want to purchase something. And so we're going to do the same basic pattern for each of our item in purchasables. Now you may notice I have a variable called item here and here. And we know that we can't step on toes and have two variables in the same method that are the same name that are different. But in this case, we can. And the reason why is because this item only lives for the duration of these curly braces. And so as long as you don't have an item declared out here somewhere, that's fine to do. Okay, so we actually have item up here and item down here, but both of them get destroyed at the end of their respective curly braces. So that's okay to do. Okay, so console.writeLine, not Windows left. There we go, right line. And we're going to do our string interpolation format and say item and then our curly braces. And we'll say item dot product name again. So this prints out the product. And then we'll say console.write. Do you want to purchase this product? Yes/no. And I put that yes/no in there to tell people exactly what we're looking for. Otherwise, you make a yep or a y or a 1 for 1 or 0. People can come up with a lot of different ways to answer in the affirmative or the negative. They might even say affirmative or negative. But if you say yes/no, then you tell them exactly what you're looking for. So string want to purchase equals console.readLine. Now, notice I'm following the same pattern I have up here, including my naming. So want to purchase, want to rent. And the reason why I'm following that naming so carefully is because then it creates a pattern in my code that makes my code predictable. Predictable is good because then whenever you see something out of band or not quite right, then you know, oh, that's probably a problem or probably bad code. Okay, so if want to purchase to lower equals yes, then item dot purchase. And that's it. And then we're done our entire application. We can actually just have a console write line that says we are done. Nothing dramatic. So now if we run this, do you want to rent or purchase something? And say the product name. Everything has a product name that's in our inventory, and everything has a quantity in stock because that's what inventory is all about. Therefore, those two things are common across every item. Therefore, we can inherit because everything is an inventory item. Okay, so now we can mix and match these. Notice that's inheritance and that's two interfaces, all in one class. And we can use this by having the same items go into two different types of lists because of their interface that we're using. Okay, and we can use that. Now we didn't have to cast anything here. Notice that. In general, if you can avoid it, do so. But if you need to, just do the if this is a or is, and then specify the type. That's just fine. Okay, just don't make it the go-to. Try and rework your code to not have to do that. In this case, I created two lists. I could have had that one list of inventory items, actually just inventory items, sorry. And then I could have done a check to say, if it's a rental, then print the rental statement. And done this loop where this loop looped through everything, but then said, wrapped all this code in an if statement that said, if it's a rental, then print it out. And that would have worked, but it would have been more memory inefficient. Okay, this is much more efficient to do it this way, having two lists and looping through the list that we need. Just kind of keep those things in the back of your mind as you're working through. Right click create anymore if we don't want to. And right now, this is a little messy still. What I could do is right click on here and say add And then we can create our interfaces. And then we'll create one for models. And then we can start moving these over to their correct location. So interface, model, interface, interface, model. So now we have our 3 interfaces, we have our 4 models, and we can actually collapse those down if you want to and just have this structure. Now, this structure is not the set in stone, this is the way to do it. Actually, typically what I do is I'll try and break up the folders by area, and then I'll have both the interface and the model right next to each other if the two are just used a one-to-one relationship. But when you have multiple, then I'll have the area folder name. So let's call it, people. So we have a whole section of stuff about people and all their information, all the different ways we do people. So I'll have a people folder. Then inside there, I'll have people interfaces and people models. And so that's how I'd break that apart. But it all depends on the size of your project and what makes logical sense. Okay. Now, one note, since I moved these over into folders, they do not have the namespace. So namespace, if I create a new one, would be .models, like so. How this system works and how these things work together, and you can better handle how to work together with all these different pieces. Okay, so that's your homework. Once you get that done, then go ahead and move on to the next lesson.